Hey everyone, thank you so much for joining for another Apache Pinot meetup. Today's topic is segment merge and roll-up task. We have two amazing speakers today that I'm going to give a little brief introduction on, and Sing-Hyun. So let me tell you a little bit about them. They're both software engineers at LinkedIn. Sing-Hyun is a senior. Oops, that happened. I don't know. I think I was something. Hopefully you guys. Senior is a software engineer at LinkedIn. He has been working on the Pinot team for 4.5 years. He is a PMC member of the Apache Pinot community, and he's contributed a lot of the Pinot core features, including replica group, aware segment routing, and custom partitioning. His main interest is to tackle the complex problems with distributed systems. And Japeng Tao is also a software engineer at LinkedIn and the Pinot team. He graduated from Northeastern University with a master's in computer science last year, and he's been working at LinkedIn for almost a year since then. During this time, he implemented broker time-based pruner and worked on segment merge roll-up features. He's really glad to contribute to open source projects and be a part of the Pinot community. So I'm just going to bring them in. Hey, guys.
Hello.
Hello.
Thank you so much for taking the time and doing this. This is really, and contributing to the project, obviously, because that's like the massive factor, but also sharing your knowledge about what you guys are working on, what you're doing and everything. It's very helpful.
Sure.
Thanks.
It's awesome. So if anybody has any questions, feel free to ask in the chat on YouTube. If you are watching this on demand on the recorded version, you're also welcome to join the Apache Pinot Slack, where you can find both Japeng and Sing-Hyun. They're both there. Or you can always ask in the general channel and things like that as well. Sing-Hyun, you said you're going to go first, so I'm going to put Japeng backstage and bring up your screen. And we'll follow up with a Q&A afterwards. If anybody has any questions, feel free to ask while the presentation is going on. And we can always just get to it. We'll probably just go in order. But feel free to ask away if you guys have any questions as things come up. Okay, this is your chance to get all the questions answered by the expert. All right. So we're going to put myself backstage and see you soon.
Thanks, Karen, for introduction. Yeah. So we're gonna get started with the talk. So for today's talk, we would like to go over. The topic is the segment merge and rollup task. So we divided the talk into 4 different sections. So we will start off the motivation on why we built this segment merge and rollup feature, and then we will go over the high-level process, how it works, and we will deep dive into the implementation details, and we will close the talk with a demo. So at LinkedIn, we operate very large multi-tenant cluster for serving internal business metrics dashboard use case. And this multi-tenant cluster is backed by hundreds of servers. And we currently serve thousands of tables. Because we have so many tables, we are operating this cluster using self-serving approach. But because of this, many of tables are currently not optimized well. And we ended up in a state where we have millions of segments in the cluster. So for example, we have observed that some tables are having tens of thousands of small segments with less than 10 megabyte sized segments. So why having too many small segments is bad? So we, for the cluster with a lot of small segments, we observed very slow operations on Helix and Zookeeper, because we have too many Z nodes in the cluster, and we also put a lot of stress in the cluster. And we also use more storage because we don't get a good compression rate with small sized segments. And also our query execution engine is based on the segment level. So we create a lot of tasks to process, and this can easily consume up the CPU resources as well. So all these impacts are added up and make Pinot cluster not so scalable. One approach to solve this problem is to fix the logic on the offline ingestion flow and merge files into a larger chunk before creating the Pinot segment. However, It is not feasible in our case because we just have so many tables, and it's not scalable to communicate with the owners of thousands of tables and ask them to change the logic and do the backfill all the data. So we decide to build this service, the merge and rollup service, that can compact segments into a larger piece inside of Pinot, so that people can optimize the table by simply adding the configuration to the table. Another feature that we wanted to add was data rollup. The majority of analytics use cases are based on time series data. And in practice, we usually need the finer time resolution only for the recent data. And we can actually, we usually don't need the full resolution for the older data. So in this case, we can round up the timestamp value and perform the aggregation to improve both query performance and the storage cost. So the example on the screen is the simple table that stores the page view count based on the user's country. So if we roll up this table into hourly, then we can aggregate 4 rows with the country value of United States into a single row. So we just need to, after we roll up this table, we just need to store 1 row instead of 4. And similarly, when we are processing the query, we just need to scan 1 row instead of 4 rows. So we just we just compressed this table, and then we also improved the query performance. So this pre-aggregation can be also be computed in the offline ingestion flow, but the same logic applies here. So we can greatly increase our developer productivity if we have the native solution inside of Pinot that can pre-aggregate this data just by enabling the config. So these are the motivations that we wanted to build this segment merge and rollup service. So segment merge and rollup service is built based on the Minion framework. And Minion is one of the Pinot core components, which is the executor engines for expensive operations, such as building the index or data purge. At LinkedIn, our main use case for Minion framework is GDPR data purge. In this case, the Pinot controller invokes the task scheduler periodically, and the scheduler decides which segments that needs to be purged. And once that decision has been made, it submits the task to the task queue, which is part of the Helix task framework. And the Pinot minion will pick up the task, download the segment, and purge the data for some members based on the lookup table. And then it uploads the purged segments back to the Pinot. In case of merge and rollup, it goes through the same cycle. The scheduler decides which segments needs to be merged together, and it submits the task, and the minion will pick up the task, downloads the segments, and compute the merge, and it will gonna upload those merged segments back to the table. So all of the minion task will follow the similar pattern where the scheduler schedules the task, and minion picks up the task and process based on the executor logic, and it uploads the processed segments back to the Pinot table. So let's take an example to see how merge and rollup works in high level. So let's assume that we have a table with 3 days worth of data. And let's say that we have the segments we have 9 segments. So on the screen, the green box represents each segment. So we have 3 different days from August 13th to 15th. And then we also have the segments from S1 to S9. And let's say, let's compute the merge over these segments. So the first thing that the scheduler does is to compute the time window that we need to process for each round. So in our case, we haven't run any merge tasks yet. So the first available time window will be the interval of August 13th to 14th. And the blue line on the screen indicates the watermark. And the definition of watermark is a timestamp that indicates all the data before this watermark timestamp has been merged, processed, and all the data are saved to backfill. So this watermark is basically the indicator of the progress of the merge task. And we also will going to use this watermark information in the future to find out find out the windows that are safe to backfill. So yeah, so the scheduler just decided that we want to process the first window, which is August 13th to 14th, and now the scheduler will going to compute the segments that belongs to this time window. So in our case, the scheduler will going to pick S1 all the way to S4 because those 4 segments belongs to the current time window that we would like to process. So segments, the scheduler will going to submit the task for this 4 segments. And then the minion will going to pick up this task and then merge those 4 segments into one. And we will get this merged segments called merged segments for August 13th. And then the minion will going to upload back this segment back to the table. So the broker side will be intelligent enough to know that we just uploaded the merged segments. So the broker will start to route to the merged segments instead of the original segments. So the gray color is the segments. The gray color indicates the segment that we no longer need to use. And then, so after this merge segments gets uploaded, we now will gonna only route to the merged segments for August 13th, and then S5 to S9. So yeah, so we just finished it to process the time window for August 13th. So we will gonna bump up the watermark because the August 13th is fully processed. So we will gonna compute the time window for the next round, and that will be the next available time window will be August 14th to 15th. And then for this time window, we now have the 3 segments, S5 to S7. And S7 is interesting because the data for this particular segment spans over 2 days. So yeah, let's focus on the S7 and how we handle this segment. So the scheduler will pick these 3 segments and then schedule submit the task submit the task so that these 3 segments can get merged. So the minion will gonna pick this task again, and then it's gonna merge those segments, and it's gonna actually produce 2 different segments. So the first merge segment will contain the data for August 14th, and then the second segment contains the data for August 15th. The reason why we partition data on time is because of the backfill. Currently, we provide the way to replace the segment based on the same segment name. But once we merge these multiple segments into one, then the file-based data boundary becomes very hard to track. So for backfilling merged segments, we now need to use the time boundary and then backfill the data by replacing all the segments for a single time window. So we would like to replace the one time bucket at a time for the backfills. So this time alignment will help us in the future because we can easily find the list of segments when we are given the time window. So after the merge task will be done, it's gonna produce these 2 merged segments, and then it's gonna upload these segments back to the table. And then the broker will now start to route to those 2 merged segments, and it's not going to route any queries for S5 to S7. So we finished it to process the time window of August 14th. So we bump up the watermark again. And then the scheduler will compute the next available time window. And now the next available window will be August 15th to 16th. And then we will going to pick S8, S9, and also the spilled over data from the previous stage. And then we will schedule those segments to be merged. And Minion computes the segment compaction, and then it's gonna upload this segment back to the cluster. So after we're done with this merge process for this table, we will now route to 3 merged segments for all the queries. And then the gray colored segments will be eventually deleted. We have a background task to do the garbage collection. We are doing it from the retention manager. And then if we want to backfill the data for August 13th, let's say, we can compute the list of segments belongs to this time window of August 13th. And then we will be able to find these merged segments for August 13th. And then we can replace these segments with the new data. Yeah, so next is how we configure the merge task. So from here, Japang will going to take over the talk.
Hi, thanks, Singing.
Thanks.
From here, I'll talk about the configurations we need for merge and rollup task. And after that, I'll have a deep dive on the end-to-end workflow. And in the end, I'll show a short demo. So this slide shows the required config we need for merge and rollup. We need a merge level name. In this case, it's 1 day. And we need the merge type is either concat or rollup. And we need the bucket time period, which is the window size of each run. And we also have the buffer time period, which is a time before a segment is ready to be merged. This slide shows a more complex example. So instead of one merge level, we actually can have multiple merge level. So in this case, it's 1 hour and 1 day. So we will merge the original data into hours first, and then it will be ready to be merged into daily granularity. So there's some other config we can do. So for rollup, we will have the aggregation tag, which is metric aggregations functions. And also we can config the run bucket time period, which is a time granularity rounding. Also, we can have some. We have 2 configs to control how the segments are generated and how much workload each task will have. So the first one is max number of records per segment. So that will control the merge segment size. So for example, if we want to merge all the data for 1 month, we probably want to split the output segments. So we can use this config to control the size of the segment. Also, the max number of records per task, which controls the single merge task workload. So again, if we want to merge 1 month's data, we don't want a single task have too much workload. So we can use this parameter to split the workload into multiple tasks. So, here I will talk about the end-to-end workflow. So as seen in previous mention, so the controller will calculate the time window for each run and also schedule segments to merge. And Minion will download and process the segments, and in the end, upload the new segments. So let's start with a cold start case. So here I'm also showing the Zookeeper, which contains all the metadata for the segments. In cold start case, so we don't the controller will scan through all the metadata of the segments, and it will get the minimum start time and run that time to the nearest bucket. So in this case, the window start time would be at the beginning of August 13th. So that will be the start time of the window, and the end time will be just simply the start time plus the bucket time. And also, as part of the controller job, it will save the watermark in Zookeeper. So once we decide the time window, we'll just pick all the segments overlapping with that time window, and the controller will create the task configs for the merge and rollup task. So the task config will look something like this. So it has information like merge type, partition bucket time period, max number of records per segment, and the input segment name, and also segment name prefix. That's a prefix for the merge segments. So this is used to avoid naming collisions between the input and output segments. So the controller will put the task config on the Helix task queue, and then it will be ready for the minion to pick it up. From the minion side, so it will download the original segments and process the merge or rollup job based on segment processor framework. Segment processor framework is a pretty flexible and generic framework. It will process M segments into N segments by doing partitioning, filtering, sorting, time rounding, etc. So once the minion has processed all the segments, it needs to upload the output segment back to the table. So from the broker set of view, so we kind of want to swap the original segment with the merge segment in an atomic way. So here, it actually uses a new protocol, which is called segment replacement protocol, which depends on a new metadata, which is called segment lineage to achieve the atomic swap. So let me jump to this picture, this slides to show the replacement protocol. So the minion will call 3 controller APIs to replace the segment. First, it will call the start segment replacement. What it does is the controller will create a lineage entry in Zookeeper. It contains information of what is the input segment, what's the output segments, and also the status. So the start will just create the status as in progress. From the broker's point of view, the broker will only route queries to the segments in the from list, but not to the to list. So after that, the minion will upload the merge segments as usual, one by one. And then in the end, the minion will call end segment replacement API. So what it does, it's just set the status from in progress to completed. So right now, from the broker point of view, the queries are routed to the segments to list. So in this case, it will route to the merge segment, but will not route to the original segments. So back to the previous slides. So as we can see here, so the controller will update the lineage metadata here. And also we can see the new uploaded segments will have a special field which in the custom map, which shows the merge level. So we covered the code start case, how this work end to end. So in the next round, we will actually have the watermark in Zookeeper. So when we calculate the time window, the controller will just read the watermark. So that the watermark will be the start time of the time window. And then the controller will try to select the segments in that window. But if the controller, when it looks through all the segments in that window, it will actually honor the segment lineage, which means it will not look at the original segments. It will only look at the merged one. So in this case, it only find a merged segment in that window, which means all the segments in that window has been merged. The controller now knows it need to bump up the starting time and end time to next bucket, and also update the watermark. So in this case, the controller will start in August 14 instead of August 13. So that covers the end-to-end flow. Here, I'll show a small demo about how this works. Here, I use a quick start example here. So you can see we have a table called GitHub events, and it has 10 segments. So from 0 to 9. For simplicity, I only have 1 or 2 records in each segment. So from if you look at the start and end time, so all the segments from 0 to 8, they only have the start and end time is the same. So which means they all belong to the same bucket. But the last segment, the end time is different. So this segment actually has data spanning 2 days. If we send a query now, so here. So if we send select constar from this table, so actually it shows there's 14 record in the table, and the number it will route to all the original segments, which is 10 in this case. So to trigger merge and roll up task, we need to change the table config. So we can just try it now. Just edit table, and I'll paste the task config here. We can just use a simple example. So we just config the data to be merged into 1 day, and we have the bucket time to be 1 day, and the buffer time is 1 day. We try to concat the data instead of rollup. So if we click save, we can see the task config is actually updated. So right now, if we go to the REST API, we can trigger the task over here. The task type will be merge rollup task, and the table name is GitHub. Sorry, typo. Oh, it actually needs a suffix, so it's GitHub event offer. This will take some time, and we can open up the Zookeeper email. Okay, so the task is done. So it actually shows a task ID over here. And if we go to the Zookeeper, we can see right now we have the task. And it shows as succeeded. So if we go to the external view, we can see here's the original segments. We have from 0 to 9. Now we have two new segments. So one segment contains data for the first date, and the other one for the second date. And also we can check the meaning, the lineage entry. So lineage entry actually shows what's the input segment, what is the output segment. In this case, the first line shows the input, all the input segments, and the second line shows the output segments, and it's completed. So if we go back to the query console, so we can send this query again. So before it actually routes to 10 segments. So if we run this again, it actually routes to the 2 segments, so which is the merge segment. Cool. That's it about the demo. And if we go back to the slides. So we have applied the merge and rollup on several experiment table in production. So we can see some table has a large number of segments. It could be larger than 30K. And after merging, the segment number drops a lot. So we can see there's above 70% compression rate. Also, for the data size, the merge and rollup can also improve the data size, but it really depends case by case. So in some case, the data size is because compressed a lot. For example, the table 4, the data size has dropped more than 17%. But for table 2, it only drops 1%. For the next steps, the feature will be shipped in upcoming 0.90 release, and it's now available in the master branch. Feel free to try it out. In the future, we can also add the backfill support. So as Xingyin mentioned before, so we kind of lose mapping between the original data from data lake to the merge segments. So we can't backfill the data per segment right now. So what we need to do is we introduce a new way to backfill the data, which is backfill per window. So we need a way to get all the segments in a certain window and replace all the segments to the new segments by group. And also in the future, we can add the real-time table support. Also, we can support other different merge type. So for example, sampling. That's pretty much I have today. So we can do the QA section.
Awesome. This is really cool. Thank you guys so much for taking the time. So really quick, just for people watching, we do have one question that came in so far, but if anybody else has any questions, please ask it now. There is a little bit of a delay from our video to the live stream. So if you're going to ask a question, better that you ask it right now, because otherwise we'll probably end it before the questions don't come in, and sometimes it takes a minute to show up. So Amrish asks, how does the segment merge work if original segment spans over multiple days? And 2, can we do roll-ups from 1 hour to 1 day to 1 month time window, etc.?
Yeah, so I think I covered the case where the original segment spans over multiple days. So what we will do is we've picked that segment, that original segment that spans over multiple days, from the time window that we first process, that the time window that falls into the the spilled over segment belongs to. So after we process it, we will gonna partition the data based on the time. So we cover the, yeah, we can merge the segment for the original segments that spans over multiple days. And then we also support multi-level rollup. So you can actually configure multiple merge levels so that you can configure it to merge segments from hours and then 1 day and then 1 month and so on. Yeah, so it is also covered. Yeah.
Awesome. Amrish, if you have any follow-up questions, feel free to ask. And this is the last call for Q&A. So, Daniel said, sorry, I missed the first part. I wonder if the size of the segments can be parametrized if it's only based on time.
Yeah, so there's a configurations that we expose to control the size of the merge segments. So we have configuration called max number of rows per segment, and then if you configure that number to be high, then we will try to merge the segments into the larger piece. Yeah. So with that configuration, you can control the output segment size.
Cool. Thank you. All right. Yu Chen asked, can we schedule the merge process, say every midnight?
So I think there is, so right now by default it will gonna schedule the merge task periodically. We trigger the scheduler every hour, but I think there was some feature added by Jackie where we can add the task configs to, so we can add the schedule time for the particular task. So yeah, so I think we can do that. Yeah.
Cool. Thank you. If anybody has any other questions, please ask now. Like I said, there's a slight delay, so it's better that you ask it now. Otherwise, we're going to be like, okay, counting down, and the question comes in after we end it. I'm just going to highlight these. We got a thumbs up from Amrish and a wonderful from Daniel. So we can give people, I guess, like another minute or two to see if anybody has any other questions. But just for those watching, if you're watching on demand or live, obviously your chance to ask right now. But if you happen to miss the opportunity, both Japong and Singyan will be in the Apache Pinot Slack. So you can ask them there, or you can also just always ask in the general channel and stuff like that too. I mean, these guys are the ones that obviously know it since they're working on it, but just feel free to ask if you guys have any questions there too. We'll include the URL for the Apache Pinot Slack in the description for the for the video. Cool.
Thanks.
Yeah, thanks.
Yeah, this is really cool, guys. Thank you.
Thanks for arranging this talk, Karen.
No, thank you for volunteering. I know it's not easy to put together a talk, and when you're doing a live demo and slides and all that kind of stuff, it's a lot of work. So it's awesome. It's appreciated, and I know the community appreciates it too. So working on it, building these things, and it's appreciated. See, you said great. Thanks for the great presentation and demo. Live demos are always scary. I'm actually really impressed that nothing went wrong. All right, cool. All right, so if we don't have any other questions here live, I guess we can kind of wrap it up. And like I said, if anybody has any questions afterwards, feel free to ask in Slack. Both of the speakers are available there, so you can ping them. Whatever. I don't know if it's okay that I volunteer you guys to be the sole answers to people's questions, but
no problem.
All right. Well, thank you guys all so much, and we will see you at the next meetup.
Thank you.
Thank you. Bye.
Yeah, bye.